Hello, dear Gurkhan students. Hope you are all doing well. Welcome back to your physics class. This is Mr. Idris, physics teacher. If you remember, in a previous lesson, we studied phase change and latent heat, section 2 in chapter 4. Latent heat is the energy per unit of mass of substance transferred at constant pressure and temperature. During the phase change, as we studied, there will be no change in temperature, and the temperature does not change, stay the same, remain constant, while the energy being added to the substance, it goes to breaking the bond of the substance and forming another bond. And also we solved all questions related with the latent heat. Today's lesson in section 3, the last section in this chapter, we're going to explain relationship between heat and work. The relationship between heat and work. Let's begin with the question: why does pulling a nail from a piece of wood, as you can see in this figure, the temperature of the nail and the wood affect the temperature of the nail and the wood to increases? Because work is done by the friction force. The work is done by what? By the frictional force. Between what? Between the nail and the wood. Okay. So this work increases what? This work increases internal energy of the iron atoms in the nail and the molecules in the wood. Similar to the rubbing your hands together. When you're rubbing your hands together, this frictional force, it goes to increase the internal energy and the work is done. So in this case, when the internal energy increases, the temperature also increases. The increase in the nail's internal energy corresponds to an increase in what? Temperature, because the relation between internal energy and the temperature is directly proportional. When internal energy increases, the temperature also increases. Guys, look, internal energy can be used to do work, and vice versa is true also. The example of the hammer and the nail illustrate that the work can increase the internal energy. The work can increase what? The internal energy of the substance. This internal energy can then decreases through what? Through the transfer of the energy as heat. When you touch the nail, you feel warm. Why? Because the energy is transferred from the nail to your body. Okay. So during the energy transfers, what happened to the temperature of the nail? The temperature of the nail decreases because the higher temperature of the nail transfers to your body, which has a lower temperature. So this reverse is also the reverse is also possible. Okay, the vice versa is true as well. Energy can transfer to the substance as heat, and this internal energy can then be used to do work. Look at this example. Consider a flask of water. A balloon is placed over the mouth of the flask. Okay, and the flask is heated. The flask is heated, and the balloon is mounted on the mouth of the flask. When the flask is heated until the water boils, okay, by giving energy as heat to the flask until the water is boiling or boils, energy transferred as heat from the flame of the gas burner to the water increases to the internal energy of the water. Okay, what happened to the water's internal energy increases when the water's temperature reaches the boiling point, 100 Celsius. The water changes phase. It convert to what? To vapor, to steam, and it becomes what? Steam. At the constant temperature, the volume of the steam increases. This expansion provides what? The force that pushes what? The force that pushes the balloon. Okay, so in this case, assume that this is a flask of water giving energy as heat. Okay, so what happened to the temperature of the water? Increases. When the temperature of the water increases, this internal energy, it goes, this gas pushes what? Pushes the balloon. Pushes the balloon. And it's gonna be expand. What happened to the balloon? It's gonna be expand. So this expanding of the balloon, it means that the heat, it goes to work done on the balloon, and the volume increased in this case. So in this case, the work is done by the gas, okay? And the outward does work on the atmosphere as shown in this figure. The steam does work, and the steam's internal energy decreases as predicted by the principle of the energy conservation. Why? Because some of this energy is transferred to do some work. Okay, so in this case, in this figure, the amount of energy is converted to heat, to work, sorry. The amount of energy, internal energy, is converted to work, okay? Because both of them is energy. The energy can be transferred from one shape to another. And also the vice versa is true. The work also can cause to increase what? Thermal energy and internal energy, okay? So internal energy is converted to the work, and work is converted to internal energy. System, what is system? A set of particles or interacting components considered to be a distinct physical entity for the purpose of the study. So this is system. An environment, the combination of the conditions and influences outside the system that affect the behavior of the system. Work done on or by gas is pressure multiplied by the volume. The work done on or by gas is the pressure multiplied by what? Multiplied by the volume change. Work done in thermodynamic system is equal to what? Pressure multiplied by what? Change volume, or volume change. Okay, so this equation can be used to determine what? Work in thermodynamic system. Work in what? In thermodynamic system. In thermodynamic system, work is defined in terms of the pressure and the volume change. Pressure is a measure of how much force is applied. What do you mean by pressure? How much force is applied in a unit area, over a given area, force divided by area. Change in volume is equal to area multiplied by displacement. Okay, so because delta V is equal to what? Length times width times height. Okay, so length times width is equal to what? Is equal to area. Area times what? Times height or distance. Okay, times height or distance. So delta V is equal to A times area times distance. Yes. Area measured in meter squared, D measured in meter, meter squared times meter, it's gonna be meter cube. Okay, so volume is equal to what? A times D. This is be substituted into the expression of the definition of the work introduced in the chapter, work on energy, to derive a new definition for the work done on or by gas as follows. Work in thermodynamic system, this is very important. What is the definition of the work in thermodynamic system? Is the product of change in volume of the gas and the pressure applied on or by the gas. What is the definition of work in thermodynamic system? Is the product, this is work in thermodynamic system, is the product of what? Product of what? Change in volume, delta V, and pressure, P times delta V. What is this? This is the definition of work in thermodynamic system. What is work in thermodynamic system? Is the product of change in volume and pressure on or by the gas. So how did we get this equation? Now I'm going to prove this equation. P is equal to delta V. How did we get this relation? This relation is based from the equation of the work in mechanical. Work in mechanical is equal to what? Is equal to Fd. Okay? So we can multiply both sides by A over A. A over A times work. A over A times what? Times Fd. A with A cancel. What does remain? Work is remain. And so you have to analyze these two areas. One of them, it goes to the denominator of the force, and the other is located here. A, D. Okay? Work is equal to what? Force divided by area is equal to what? Pressure. A times D is equal to what? A times D is equal to what? Change in volume. A times D is equal to change in volume. Okay? Change in volume. So in this way we can prove the equation of work in thermodynamic system. Okay. So this is the equation of work in thermodynamic system. Work done by gas or on gas is equal to P delta V. So we have two equations. Work is equal to P delta V If the change in volume is not given, you have to open. Okay, it's gonna be what? V2 minus V1, V final minus V initial. Okay, so this equation can be used when volume is given in the question or unknown. Okay, and another equation, work is equal to what? PdA. So this equation also can be used when area or distance is given in the question. These two equations can be used to determine work in thermodynamic system. The first two equations can be used when volume is given in the question, and the second one when radius, distance, area is given in the question. You have to use the second equation. Work is equal to pressure, distance, area. This equation can be used to find work in when distance, area is given in the question or unknown. P delta V when the volume. If the gas expands, in the case of expands, if the gas expands, in the case of expand, guys, look. Expand, delta V is gonna be positive, and the work done is gonna be positive, and the work is on the gas. Work is on the gas. Because we have two cases, work on the gas and work by the gas. Work on the gas. So delta V, when does delta V becomes positive? In the case of expand. Work in thermodynamic system also is positive, and the work is done on the gas. The second one, if the gas is compressed, delta V is gonna be negative, and work done is gonna be negative, and the work is by the gas. The work by the gas here, sorry. Look, here the work is by the gas does work on the piston, and the work by the gas, on the gas, sorry. In the case of expand, the work done by the gas, but in the case of the compression, the work done on the gas. Okay, the work here by the gas, yeah, by the gas, but in the case of the compressed, the work on the gas. The work is compressed on the gas, and it becomes smaller, and delta V work becomes negative. When the gas volume remains constant, when the volume does not change, at constant volume, there will be no change in the volume. The work done on or by the gas is equal to 0. When does work done become 0? If V1 is equal to V2. No change in volume. No change in volume. How? For example, in a hot day, when the car is packed in a hot day in the summer, what happened to the temperature of the car, inside the car? The internal energy increases. Okay? So this energy transfer from the sun of the light and enters the car. What happened to the car's internal energy? Increases. But this increasing of internal energy does not cause to work done on the car. Why? Because the volume of the car doesn't change by increasing temperature. Okay, when the car is packed in a hot day in the summer, the volume of the car does not change. So when the volume doesn't change, it means that there is no work done on the system. Okay, and work done is equal to 0. Delta V then also equal to 0. What does work in thermodynamic system depend on? It depends the pressure of the gas change in volume. When does the work done by the gas will be positive, and when does it be negative, and when does it become 0? For the positive work in thermodynamic system if the gas expands. Delta V positive and work done by the gas on the piston is positive. Okay? But in the case, when does it becomes negative? If the gas is compressed. Delta V is negative and work done by the gas on the piston is negative. Okay? When does the work done by the gas will be zero? When does work on the gas become zero? When the gas volume remain constant, doesn't change. There is no displacement and no work is done on or by the system. If diameter is given, sometimes the diameter is given. So this is the circle, okay? This distance from this distance is called diameter. What is this? This is diameter, okay? But we have also radius. What is radius? Half of diameter, okay? Radius is equal to what? Is equal to diameter divided by 2. For example, if this diameter is 3 meter, radius is equal to what? 1.5 meter. Why? Because radius is equal to 3 divided by 2, 1.5 meter. Whenever diameter is given in any question, to determine the radius, you have to divide the diameter by 2. And also, how can you determine the area of the circle? The area of the circle is equal to what? Pi r squared. Guys, according to this equation, work in thermodynamic system, PdA. For example, if area is not given, how can you find area? Area is equal to what? Pi r squared. When r is not given, instead diameter is given, r is equal to what? Diameter divided by 2. Okay? Okay. When diameter is given, you can convert to radius divided by diameter divided by 2. Look at sample problem 4D. An engine cylinder has cross-section area. What is this? This is area. How much work can be done by gas in a cylinder if the gas exerts constant pressure? This is pressure. We have area and pressure. And the moves the piston at a distance 0.04 meter. Okay? So, what is unknown? The work done. How much work can be done by the gas in the cylinder? So work is unknown. Which equation can be used? This equation can be used. Pressure, distance, area. Why? Because we have both area and distance. Okay. So because if the gas exerts a constant pressure on the piston and moves the piston a distance 0.04 meter, this distance it should be negative, but it is okay, it doesn't matter. So work is equal to what? Do we have pressure? Yes. 7.5 times 10 to the power 5 times distance 0.04, area was given 0.01. Work is equal to what? You can use your calculator to find the final result of the work in thermodynamic system in this question. Look, 0.01 times 0.04 times 7.5 times 10 to the power 5. I got 300 joules. Yeah, 300 joules or 3 times 10 to the power 2 joules. This is sample problem. Practice 4D question 1. Look at this question. Gas in a container is at a pressure. What is this? This is pressure. And volume 4 meter cube. We have pressure. Pressure is equal to 1.6 times 10 to the power 6 Pascal. And V1 is equal to 4 meter cube. What is the work done by the gas if it expands at a constant A? If it expands, it means that V2 must be bigger than V1. At constant pressure to twice it is initial volume. What do you mean by twice it is initial? Initial volume is equal to what? 4. V2 is equal to what? Twice of initial volume is equal to 2 times 4. It's going to be 8 meter cube. So work is equal to what? P delta V. P V2 minus V1. Work is equal to P, replace, 1.6 times 10 to the power 6 V2 we didn't have but was given indirectly. 8 minus V1 4. Work is equal to what? 1.6 times 10 to the power 6 times 4, which is equal to 6 point times 4, is equal to 6.4 times 10 to the power 6 joule. This is branch A. When it expands, work is positive. Delta V is positive. Branch B, when it's compressed, in the case of compressed to what? To 1/4 of it is initial. 1/4 of when V1 is equal to what? 4 meter cube. When it's 1/4 of it is initial, 1/4 of it is initial volume, it means that V2 is equal to what? 1/4 times initial volume, which is equal to 1 meter cube. So V2 is equal to what? 1 meter cube, because the 1/4 of 4 is equal to 1. Work in thermodynamic system in the branch A is equal to P V2 minus V1, 1.6 times 10 to the power 6 times V2, 1. V1, 4. 1 minus 4 is equal to negative 3. Work is equal to negative. Why? Because it's compressed. Okay? And 3 times 1.6 is equal to 4.8 times 10 to the power 6 joules. What does negative sign indicate here? It means that the system is compressed. Okay? The work is still done, but the system is compressed and the volume reduced. The change in volume is reduced here. This is question 1. Question 2, very easy. A gas is enclosed in container fitted with a piston. The applied pressure is, what is this? This is pressure. But guys, be careful. This pressure is given 599.5 kilopascal. You have to convert to Pascal. Multiply 10 power 3. P is equal to 599.5 times 10 to the power 3 Pascal. Okay? It's not allowed solving with kilo. You have to convert, multiply by 10 power 3. In which change volume in the gas from this is V1 to this is V2. How much work is done? Okay. V1 is equal to this number. V2 is equal to 2.523 times 10 to the power negative 4. Work is equal to what? P delta V. P V2 minus V1. Pressure after convert 599.5 times 10 to the power 3. V2 2.523 times 10 power negative 4 minus V1 5.317 times 10 to the power negative 4. By calculator, you can determine the value of the work in question 2, which is equal to negative 165 joules. Why? Because V1 is bigger than V2. When V1 is bigger than V2, it means that compressed. For the compressed, delta V is negative. Work done also is negative. Question 3. Guys, look, question 3. A balloon is inflated with the helium at constant pressure. This is pressure. Exceeds the atmosphere if the balloon inflated from the volume 1.829. So V1, V2. Which one is bigger? V2 is bigger than V1, so delta V is positive. Work also positive. Work is equal to what? P V2 minus V1. Pressure is equal to what? 4.3 times 10 to the power 5. V2 9.5 times 10 power negative 4 minus 1.8 times 10 to the power negative 4. Okay? Work is equal to what? In question 3. Work is equal to 3.3 times positive, 3.3 times 10 to the power 2 joules, or 330 joules. The last question, question 3. The last question, guys, look. Question 4, sorry. A steam moves into a cylinder of a steam engine at constant pressure and does work. This is work. The work is given in question 4. Guys, look. Work is equal to what? 0.84 joules. On a piston, the diameter of the piston is given. Diameter is given is equal to 1.6 centimeter. You have to convert to radius, after that convert to area, because we need area. Be careful. Whenever the diameter is given, you have to convert to radius, after that convert to area. How can you convert to radius? Radius is equal to what? Look, diameter divided by 2. 1.6 divided by 2 is equal to 0.8 centimeter. Convert to meter. How? Multiply 10 power negative 2. Now radius is equal to what? 0.8 times 10 power negative 2 meter. After that convert to what? Area. Area is equal to what? Pi r square. Okay? Look. So for any question when diameter is given, you have to do the same process. Okay? And the piston travels 2.1 centimeter. This distance is equal to what? 2.1 centimeter. Convert to meter. 10 power negative 2. D is equal to 2.1 times 10 power negative 2 meter. And what is unknown? What is the pressure of the steam? Pressure of the steam. So we have to use this relation. Work is equal to what? PdA. Pressure is unknown. Is equal to what? Work over what? dA. Do we have work? Yes. 0.84. Do we have distance? Yes. 2.1 times 10 power negative 2. Do we have area? No. But we have pi r square. Pi r is equal to what? R we found 0.8. 0.8 times 10 power negative 2 square. So P is equal to what? P is equal to 2 times 10 to the power 5 Pascal. Okay, that's all for today. Thank you for listening. Inshallah, in the next lesson, we will continue explaining the other topics. Have a good time and keep up your best doing.